Imagine that you are holding a photograph of yourself as a child. You look at the face in the picture, and you know that person is you. There is an unbroken chain of cause and effect that connects that moment in the past to the present moment you are experiencing now. That child grew up day by day, meal by meal, breath by breath to become the person you are today. The past flows seamlessly into the present. Now imagine you're looking at a photon of light, a tiny fundamental packet of energy, perhaps from a distant star entering your eye. You are seeing it, experiencing it. The question is, how old is that photon? When was it born? The intuitive answer seems simple. If the light came from a star 100 light years away, the photon must be 100 years old. It was created in the heart of that star, and it has been traveling through the vacuum of space ever since, finally ending its journey in the back of your retina. But that's only true if you think of a photon as a tiny, persistent thing like a cosmic marble that endures through time. But is light a thing in the way we think of things? Is its journey through time the same as our own? This is where we must slow down. We must push past the simple answer and start asking questions in the way a curious child would, or in the way a certain physicist with a distinctive draw might approach a puzzle. We have to follow the thread of logic, no matter how strange the pattern it weaves. And if we follow it far enough, we will arrive at a conclusion so bizarre, so counter to every instinct we have, that it will force us to reconsider not just the nature of light, but the nature of time, the universe, and our very existence within it. We will be forced to ask, could light in a very real sense be older than the universe itself? To begin, we need to understand what a photon is. Not in a textbook sense, but in a felt sense. Think about a wave on the ocean. You see it cresting, moving towards the shore, and it feels like a distinct entity. But is the water itself moving with the wave? Not really. The water molecules are mostly bobbing in place, moving in a circle. The wave is a pattern of energy moving through the water. The photon is a bit like that, but instead of moving through water, it's a ripple in a field. In modern physics, we don't think of particles as tiny little balls. We think of fields that fill all of space: an electron field, a quark field, and an electromagnetic field. What we call a photon is just a tiny localized excitation, a little quiver or wave packet in that underlying electromagnetic field. So when a photon is emitted by an atom in a star, it's not like the atom was carrying a bag of marbles and threw one out. It's more like the electromagnetic field was calm in that spot, and then a disturbance was created. That disturbance ripples outward. The photon is the rippling. Here's the first deep cut, the first place where our intuition begins to bleed. How does that ripple experience its own journey? We as massive beings are permanently anchored to the arrow of time. We are born, we age, we die. The past is a memory, the future a mystery. For us, time is a river we are forced to sail down. But for a photon traveling at the speed of light, the rules are completely different. They are not just different, they are, from our perspective, non-existent. Einstein's theory of relativity tells us that as you move faster, time slows down for you relative to a stationary observer. This is not a metaphor. It's a physical fact tested and confirmed millions of times with atomic clocks on airplanes. As you approach the speed of light, time slows to a crawl. If you could somehow reach the speed of light, which you can't because you have mass, time would stop completely. From your perspective, the journey would be instantaneous. A photon is the one thing in the universe that does travel at that ultimate speed. So from the photon's point of view, if we can even use such a phrase for a ripple in a field, its entire existence from its birth in the core of a star billions of years ago to its death in the retina of a human eye on a distant planet takes exactly 0 time. Think about what this means. A photon created in the first few moments after the Big Bang, a photon that has traveled for 13.88 billion years across the expanding cosmos, has not experienced a single second of that journey. For the photon, its emission and its absorption are the same event. They are simultaneous. The vast, incomprehensible age of the universe is for a photon compressed into an eternal, timeless present. It is born, and in the very next instant of its existence, it ceases to be. There is no in-between. This is our first paradox. We see a star in the night sky. We say that light is ancient. It began its journey before humans walked the earth. And that is true from our perspective, anchored in time and space. But from the perspective of the thing we are observing, the light itself, it is brand new. It has no age. It is in a sense timeless. So how can we even ask the question, how old is light? The question itself seems to break down. But let's push further. Let's not just stop at the mind-bending fact that a photon doesn't experience time. Let's look at the light in a different way. We say the universe is 13.8 billion years old. That number is based on measuring the oldest light we can see, the cosmic microwave background radiation. This is the afterglow of the Big Bang, light that was finally able to travel freely when the universe cooled down enough to form neutral hydrogen atoms about 380,000 years after the beginning. We can detect this light, we can measure it. It is, in a way, a cosmic fossil. We are absolutely certain that this light is almost as old as the universe itself. So on the one hand, we have a photon from the CMB that is, by any human measure, 13.8 billion years old. And on the other hand, from its own frame of reference, it is ageless, experiencing its own birth and its absorption by a radio telescope in one timeless instant. This is the contradiction at the heart of our question, which is the true age? To answer this, we have to stop thinking of the photon as an object and start thinking of it as a relationship. A photon is not a thing that exists in space and time. It is a process by which information and energy are transferred from one point in space-time to another. It is a connection. Its entire purpose, if you can call it that, is to couple one event emission with another event, absorption. The universe is not a stage with objects moving around on it. It is a woven fabric of events, and light is the thread that connects them. This brings us to an even more profound idea, one that was central to Richard Feynman's own work. It's called the Wheeler-Feynman absorber theory, and later evolved into something called the transactional interpretation of quantum mechanics. It is one of the strangest, most beautiful, and most unsettling ideas ever conceived. The standard view is that a light source like a candle sends out waves in all directions, and some of those waves hit your eye. It's a one-way street. But Feynman and his doctoral advisor, John Archibald Wheeler, considered a different possibility. They wondered if this one-way street was too simplistic. What if the process of light is not a broadcast, but a conversation? Imagine you are in a huge, empty auditorium. You shout, "Hello." The sound waves travel out, hit the walls, and then echo back to you. The echo is a response to your shout. Wheeler and Feynman asked, what if on a quantum level, something similar is happening with light? What if when an electron in an atom is excited and wants to emit a photon, it doesn't just blindly shoot one out into the void? What if it sends out a kind of offer wave, a faint probabilistic whisper into the future? This wave travels out into the universe, moving forward in time. Then somewhere in the future, there is an atom that is capable of absorbing that specific photon. That absorber atom responds by sending a confirmation wave backwards in time to the original emitter. This confirmation wave travels from the future to the past. When the original emitter receives this confirmation from the future, the deal is sealed. The handshake is complete, and only then does the actual exchange of energy, what we call a photon, occur. In this view, a photon is not a little ball that travels through time. It is a transaction, an agreement between the past and the future. The act of emission and the act of absorption are two sides of the same coin. They are correlated events that define each other. An atom can't emit a photon unless there is an absorber somewhere in its future to receive it. The future, in a sense, determines the past. This flips our entire notion of causality on its head. We think the present causes the future, but this interpretation suggests that the future also has a hand in shaping the present. The universe on a quantum level is not a one-way progression from cause to effect. It is a giant interlocking web of echoes and responses of offers sent forward and confirmations sent back, creating the reality we experience in the sliver of time we call the present. Now let's apply this to the question of the age of light. If a photon is a handshake between the past and the future, then its age is a meaningless concept. The transaction exists outside of our linear experience of time. The photon that you see right now is not a relic from a star that died a million years ago. It is the culmination of a process that involves both that star's death a million years ago and your act of seeing it today. Your eye here in the present is a necessary participant in that photon's existence. Without you or something else to absorb it, the photon's reality is not fully realized. It remains a possibility, an offer, waiting for a response. This is where we arrive at the most profound implication. Go back to the cosmic microwave background. Those photons are the oldest things we have ever observed. They were emitted when the universe was just an infant. They have been traveling for almost the entire history of the cosmos. But according to the transactional view, their journey is not yet complete. They are still offer waves traveling through space, waiting for an absorber. For 13.8 billion years, these offers have been echoing through an expanding universe, most of them destined to travel forever, never to be absorbed, their transaction never completed. But some of them, a tiny fraction, eventually encounter something. They encounter a particle of dust, a molecule of gas, or the carefully crafted metal of a radio telescope on a planet that didn't exist for most of their journey. At that moment of absorption, the transaction is completed. The future in the form of the telescope reaches back and shakes hands with the past, with the infant universe. So how old is that photon when it is finally absorbed? By our clocks, it is 13.88 billion years old. But its reality, its existence as a completed thing, only happens at the moment of absorption. In a sense, it wasn't truly a photon during its journey. It was a half-realized potential, a question mark, traveling through the void. It only became a full-fledged particle, a real entity at the moment it met its destiny in the present. It was born in a very real sense, not in the Big Bang, but in the detector. This leads us to the haunting conclusion of our original question. Could light be older than the universe? If we define the universe as the totality of space and time that began with the Big Bang, then the light we see from that era is by definition as old as the universe. But consider this, the universe itself is a process. It is an ongoing event. Its age, 13.88 billion. Years is the measure of time that has passed since that initial event. But the experience of the universe, the act of it being observed and known, happens in the present. The universe of the past is only real insofar as it leaves traces, fossils, memories, and light that are encountered in the present. If a photon's full reality depends on its absorption in the future, then the light from the early universe is in a very real sense younger than the universe. It only becomes real at the moment of its detection, an event that occurs billions of years after the universe began. Its life as a tangible phenomenon is not the long, lonely journey we imagine, but the instantaneous act of connection between then and now. But flip it around. Think about the nature of the transaction. The confirmation wave travels backwards in time from the absorber to the emitter. From the perspective of the universe's timeline, the future event, the absorption, precedes the completion of the past event, the emission. The handshake is simultaneous, but the arrow of the confirmation goes against the flow of time as we know it. This suggests that the photon, as a completed transaction, exists in a kind of eternal now that connects all moments. In that sense, the relationship that the photon embodies is older than any single moment in the universe. It is a link that predates the universe's expansion and postdates its eventual fate all at once. Perhaps the most poetic way to think about it is this: you sitting there watching this are made of atoms. The carbon in your body, the oxygen you breathe, the iron in your blood, these were forged in the hearts of ancient stars that lived and died long before our solar system was born. You are literally made of stardust, but the light from those stars, the light that once shone in their fiery cores, has been traveling. Some of it, the tiniest sliver, has ended its journey by interacting with the atoms that now make up your body. The atoms that are you were, in a sense, waiting for that light. The transaction between the ancient star and the present day you was completed in the very fabric of your being. You are not just made of star stuff. You are the destination for the star's light. You are the future that reached back and shook hands with the past to create the reality of the present. So how old is the light that dances in your eye? It is as old as the universe. It is as young as the present moment. It is the universe's way of knowing itself, a thread woven through the fabric of time, connecting the beginning to the end. The photon is not a traveler through time. It is a bridge across it. And on that bridge, past and future meet in a timeless embrace, and for one brief flickering instant in the act of seeing, the universe becomes aware of its own magnificent, ancient, and ever-new existence. The light is not older than the universe. It is the universe touching its own face across the abyss of time.